Hi, I'm Kate, and today I will be complaining about end-to-end testing. To set the mood, let's set the mood. Honestly, I think there's too much happiness going on. And before I explain, a quick question. Can you please raise your hand if you have automated tests for your multi-factor authentication flows? We've got a couple of people in the room who are experts and probably know better than me that it's tricky. You need to set up test account, configure authentication providers, and sort out a dozen of other things to be able to test full, happy path multi-factor authentication flow. And our team was busy thinking about all these details when a nasty bug slipped in. Imagine a typical two-factor authentication screen. This is GitHub, but they are all kind of the same. Normally, when user enters wrong code, they should see an error, of course. But in our case, because of a bug in the error handler, the users could enter the system with literally any code. We were so busy thinking about happy path testing that this critical issue went almost unnoticed. My takeaway from this story is that we should shift our thinking from happy path flows to business critical flows, which are not always happy. Of course, we won't be able to test everything, but at least we should be able to test what's important. And of course, a reminder that bugs happen. Just yesterday, our team was fixing one of them. Because we do deploy on Friday. Now, probably the only thing that is more annoying than bugs is test flakiness. We all know this feeling when test runs, you run it again, and it fails. In fact, it's so annoying that some of us gave up on end-to-end testing completely. Today, I want to challenge that a little bit and remind us that for years, technology has been embracing flakiness of our imperfect world. One example is network. Wi-Fi is constantly dropping, shuffling packets containing our data, and yet the entire world is connected. In fact, someone is watching this conference right now far away from Alicante. If we could solve that, we must be able to solve test flakiness. So let's dig deeper. And for that, I will need a flaky test. I've got this simple quiz application, and I will attempt to test it with Playwright. I've got this empty test here, and what I'm going to do, I will click the button with the right answer, and I will expect the correct status text to be displayed on the screen. As simple as that. So the first thing to do is to open a thanks cursor. That looks good. Let's see if that works. Now what I need to do, I need to click the button with the right answer. I will say await, page get by role. It's indeed button, it's not a link. Alicante, no, not that. Alicante, good enough. Now, now I need to verify the status text. So let me first grab it. Yeah, good enough, thanks. And what I will expect status to be correct. Yeah, something like that. Let's run it. It works, great, I can commit it and be done with that. But in fact, I intentionally made this test flaky. So let me prove it to you. I will run this same test. Let me clean that for us. I will run this same test multiple times. Now Playwright is rerunning this test 20 times, so we can see that sometimes it randomly fails. Let me run it again, because this is what we do with end-to-end tests. We rerun them all the time. So you can see that sometimes it fails. In this case, it failed 8 times out of 20. So now let's fix it. Anyone, any idea? Okay, let me make it much, much easier for us. And for that, I will re-enable ESLint that I disabled for the purposes of this demo. If I now go back, you can see my code contains an error. If I check it, it says replace text content with to have text. And this error comes from Playwright prefer web first assertions rule. Let me just apply it. It's auto-fixable. Let's run again. That works. Let's run again, that's it, 50 times. So I have 3 screens over here, but honestly, I don't need them to know that my test is passing. It's this level of confidence we need when we run our tests. Now, let's understand what fixed the issue. And for that, let's go back, I'll remind what we changed. So it was text content, and after the fix, we switched to something called to have text. Do you want to update now? No. So let me run Playwright again, but now with debug logs, so that we can see what Playwright is doing under the hood. I have somewhere here, no, not that. Debug command. Don't worry about all these logs, let me make it bigger, and I will walk us through what's happening here. And the interesting part starts here, expect to have text with timeout 7777. It's a lucky number, you all need to configure it for your test to pass. Actually, its configuration, by default, it's just 5 seconds, I reconfigured it for fun. The first thing that happens here is that Playwright tries to resolve the locator, get by roll stages. And on the first attempt, it receives unexpected value, empty string. So just tries again, and again, and again, until it finds the value it expects. The alternative outcome could be that it fails with timeout error. It's as simple. Now, let's check how click action works under the hood. Let me scroll to the click action here. So the very first thing that Playwright is doing, it's trying to resolve the locator again. And this time we were lucky. It was already on the page, so we found the locator. So the next thing is to click the button. And before clicking the button, Playwright actually checks actionability of that element. It checks that the element is visible, enabled, and stable. And in our case, it was not enabled. Maybe the application didn't load yet, maybe there was some business logic going on that keeps the button disabled, so Playwright tries again. And after 20 milliseconds again, until it finds the button in the correct state. After that, it clicks the button and the test continues. So to recap, Playwright web first assertions under the hood are just intelligent polling. Additionally, it performs actionability checks before interacting with the elements, which makes interactions much more stable. The checks depend on the type of the element you interact with. If you want more granular control, there are low-level APIs for you to configure, for instance, polling intervals. My takeaways, well, first, embrace linters. There are all sorts of them. They are great for learning on the spot. But for me personally, it was also very useful to understand how Playwright works under the hood. With this knowledge, my test code became much more stable. So now, for a moment, let's assume our tests are not flaky anymore and move on to the next problem. And of course, it is speed. End-to-end tests are slow by definition. When something is slow in software development and we can't make it faster, we try to break it down into smaller things and run in parallel. That's exactly what we did a year ago. We used to run tests in 3 workers, and it was taking around an hour. We switched to 12 workers, and it was taking less than 20 minutes. Good news, it was very easy to do with Playwright built-in parallelization. Bad news, every other optimization required a lot of hard work. And this is why. Here, at the beginning, you can see this white space. This is waste, because we have a couple of tests that are serial, sequential, and they are not easy to run in parallel. They block the entire optimization. In parallel computing, this phenomenon is known as Amdahl's law, and it basically states that benefit from parallelization is strictly limited by the amount of sequential code you've got. Another contributing factor is the performance of application itself. Here, that's not it. Here, on a busy day, when everyone is running a lot of tests, they are failing because the application itself is slow. Someone may say that this is flackiness, but it's not. Tests are failing because poor performance is a bug, and tests are simply stating that. So my takeaway from this is kind of obvious. First of all, invest in full parallel mode as soon as possible. It's practically the only way to scale your end-to-end tests. Poor performance is a bug, and sometimes our end-to-end tests act as performance tests, and we have to invest in application performance. Explore different types of cache available. One option is Playwright Network Cache that reduces load on the server. But even when all of that is done, sometimes we need to delete tests. Just like any code, test code can and should be deleted. Often, things are hard because we misuse or overuse the tool beyond its intended limits. I want to remind us that end-to-end tests are just part of a bigger picture. I want to welcome you to explore the different testing strategies and shapes out there. The classic testing pyramid. It's more modern evolution that adds more tests to the spectrum. Of course, the testing trophy from Ken C. Dodds that puts more focus on the integration tests. The ecosystem gets better and better. And honestly, there are less and less things to complain about. I did my best. My name is Kate. I'm collaborating on all social media. Thank you.